Well, I think we have to recognize that we're very far away. We're off track. In terms of high-level climate ambition, Paris Agreement, we're off track globally. And we're off track in most sectors and in most countries. So we do need sustained, targeted, deep efforts that will address decarbonization and climate change across a range of sectors. And aviation, obviously being a very important part of the global economy, is one of those sectors.
Welcome to the Aerospace Ambition Podcast. I'm your host, Marius, an aerospace engineer dedicated to exploring sustainable aviation and the role of AI. In today's episode, we'll delve into the important topic of aviation's non-CO2 effects, with a special focus on contrail management. My co-pilot today is Alejandra Martin Frias. Alejandra is the head of contrail research and sustainability at FlightKeys and is deeply involved in aviation contrail management through her industrial PhD. And if her name sounds familiar, you're right. Alejandra was a guest in episode 6 of this podcast, and it's a pleasure to have her back today, and this time on the other side of the microphone. Welcome, Alejandra.
Thank you, Marius. Well, to be fair, he begged me to come back, so I had to return. But yeah, I'm extremely happy to be back. Thank you for having me. A lot of things have changed since the first episode. And I'm especially very happy to be here with our guest, since he's known as a celebrity within the contrail world.
Absolutely. That's definitely the right term, because today's guest is Professor Marc Stettler, a leading expert in transport and environment from Imperial College London. He directs the Transport and Environment Laboratory and has a strong focus on reducing the climate and health impacts of transportation, particularly through his work on emissions and air quality. With a background in physics, maths, and engineering, Marc's research covers multiple modes of transport, including aviation, and aims to make vehicle emission data more transparent. He's also actively involved in several committees and advisory groups focused on sustainability and air pollution. Marc, welcome to the show.
Thank you, Marius. Thank you for the introduction. I'm not sure I should be called a celebrity. That makes me very uncomfortable, but thank you very much, Alejandra.
We expected that reaction.
Such a celebrity reaction, I have to say.
Absolutely.
So modest.
Absolutely. However, congrats to your recent promotion. You're a professor, well-deserved. And maybe to start off with a personal question here, can you tell us a little bit about your experience in academia and how you ended up at Imperial and what your journey was into the non-CO2 aviation domain, let's say?
Or how I wanted to phrase the question, who's the man behind the legend?
How long have you got? Well, so I was always interested in science. I have to sort of think back to when I was a young kid. I loved watching science programs on TV. Then when I was doing my exams at school, we do A-levels in the UK at 18. Firstly, I had to decide which subjects I wanted to do. So I did science subjects and maths. I did maths, physics, chemistry, biology at A-levels. And I really enjoyed them all. So I had to kind of decide what to do at undergraduate level. And I think I mostly enjoyed physics and maths. I kind of felt more familiar with them, more comfortable with them, although I still wasn't very good. So, I didn't get into everywhere I wanted to go at that point. I was still pretty naive. I think I learned how to pass exams as you kind of do. You learn how to pass exams. So I probably wasn't the all-rounded mathematician that some people are at that stage. But anyway, I did natural sciences with physics and maths at the University of Durham. I spent 3 years there, and towards the end of my third year, I was looking at what I could do. I could stay on there and continue for another year, or I could do something else. And I'd started to read around the topic of climate change. IPCC reports were sort of coming out at that point. There were some more lectures about energy and renewable energy in Durham that were happening that I went to. Also, it was the first sort of EU ETS, the emissions trading scheme, was starting to be spoken about back then. And I read a book called Heat by George Monbiot, which was he's a journalist, he's still active, and he's talking about different solutions to climate change. And I was really inspired by that kind of more action-oriented view. And I ended up doing a master's, MPhil in sustainable engineering with sustainable development, or engineering for sustainable development at the University of Cambridge. That was a year. Did my project on aviation and travel choice with Andreas Schaefer. Enjoyed my project. Never really knew that I was going to do a PhD, but then I really enjoyed research. So I applied for a PhD position with Stephen Barrett, which was looking at airports and air quality impacts. So proceeded with that. Stephen moved to MIT, and I was lucky enough to be taken on by another supervisor, Adam Boyes, who had an experimental background. And for me, that was really helpful and transformative in a way, because I then combined the modeling work that I'd been doing with Stephen with some experimental work that Adam was able to guide me through. And I think that's a really nice perspective to have. And then I did a couple of years as a postdoc with Adam, looking at heavy duty vehicles and emissions, and actually going and doing measurements of emissions from trucks, and got my position here at Imperial in 2015. And the first PhD project that I kind of advertised was on essentially non-CO2 effects of aviation, because we wanted to understand the emissions of particles from aircraft engines. In my PhD, I'd looked at it in terms of a mass basis, what massive emissions are coming out of aircraft engines of these particles. But I wanted to turn that into a number estimate, because I knew, and we knew from the literature, Bernd Karcher's work, etc., that the number of particles is very important in determining the properties of the contrail, how many ice particles there are in a contrail initially, and then how long that contrail persists, to some extent is determined by how many particles are emitted initially by the aircraft engine. And so that's where we started with Roger Tier's PhD. And since then, we've been able to kind of continue that work, collaborate with industry, and think about not only developing the scientific understanding, but understanding around how contrail avoidance could be implemented in the real world and the reasons for doing that. So we still involved in science, still involved in research that is looking at fundamentals, but also very grateful to be involved in collaborations where we're thinking about how to actually take action in the real world.
Wow. That seems like a great story. I didn't know all of this information about you. I mean, Steve's kind of, like not surprising, but it was not a clear straight line to non-CO2. So I'm very glad that you end up joining the non-CO2 team. And also, I don't know if you know that, but you are the reason why Flight Keys and myself ended up in non-CO2 to begin with. We attended the Royal Aeronautical Society event I think it was 3 years ago already, when it was still COVID times. We attended online and we heard Marc's presentation, and it was so inspiring, so good, that we decided to look into it ourselves. And since then, many things have changed. So my first question would be, you said you've been with Roy Tio, looking at non-CO2 since 2015. I joined 3 years ago, and already in these 3 years, many things have changed. So for you, what would you say are the biggest changes that have happened in terms of science since you began until now?
So in terms of science, we have a better understanding of the role that particles play in initial contrails through measurements that are conducted by DLR and NASA. We have evidence now that changing the fuels affects particle emissions, and therefore that changes the properties of contrails initially. So there's a lot of data on that now. And looking back to 2015, 2016, we didn't have that data. So there's huge advancement in that. We also have huge advancements in remote sensing capabilities. So the use of satellites to look at contrails and how they evolve over time. Again, that was not something that we had back 2015. At that time, we had a lot of modeling results, and we still have a lot of modeling results. And I would say in terms of the model estimates of contrail rated to forcing, those have been pretty consistent. I would say there's not been a revolutionary change in our understanding of the net effect of contrails from model studies. And what I would say is then that there is greater experimental evidence or empirical evidence that, firstly, that those model estimates are in the right order of magnitude. Of course, there's variability and uncertainty, but also that we've got greater understanding of the processes and mechanisms affecting the formation and lifetime of contrails. We don't know everything, but we have a much better understanding.
Yeah, and this much better understanding leads to also, I'd say, more clear calls to action, for example, through papers. And this is the important role that research plays in there, right? Not only gathering the evidence or also quantifying the understanding that we have, but also whether it's in the abstract or whether it's in the conclusion, also hint at potential solutions. And an important role that is played in there is, or an important role plays the Aviation Impact Accelerator, for example, which published a paper very recently in September 2024, that is. And the paper was called 5 Years to Chart a New Future for Aviation. And I'm discussing this right here because obviously contrail management, given, the knowledge that we have right now, has been mentioned as one of the key pillars to achieve sustainable aviation in the long term. However, before we dive into that, another, let's call it pillar that was mentioned in there was called moonshots. And when I read this, I had, two feelings. First thing is, I mean, this is the Aerospace Ambition podcast, so moonshots are an ambitious thing to do, right? So that's great. But the second thing is, isn't it a little bit frightening that some of the best things, that we should do right now are called moonshots?
Frightening in what respect?
Frightening in a respect that we are far away from achieving that.
Well, I think we have to recognize that we're very far away. We're off track. In terms of high-level climate ambition, Paris Agreement, we're off track globally. And we're off track in most sectors and in most countries. So we do need sustained, targeted, deep efforts that will address decarbonization and climate change across a range of sectors. And aviation, obviously being a very important part of the global economy, is one of those sectors that is also, because of how it operates, because of its use of high technology, aircraft that are very sensitive to weight, because we're putting things up into the air, we can't be carrying a lot of weight around. So it's actually a sector that is harder to decarbonize than other sectors. So while the pathway for decarbonizing road transport, for instance, would appear to be clearer, we have various options, predominantly electrification. For aviation, it's much more difficult to have technical solutions to that will reduce the climate effects. And technical solutions will be needed, but there will need to be extreme effort, investment of time and people and resources into solving these challenges. So I think moonshots is the right framing. If we continue to think about it in the way that we have done for the last couple of decades, we will continue to make progress at the rate that we have done over the last couple of decades. And that isn't aligned with the overall climate targets that we have. So yeah, I think the moonshot framing is right. And we need to think about kind of ways in which we can accelerate innovation, bring research into the real world, but also in a collaborative way, so that we do accelerate those innovations that are going to help decarbonize aviation.
But then, as a quick follow-up, given your experience not only in aviation, but before you mentioned, also the automotive or general transportation, do you understand this discourse that maybe we shouldn't be looking into aviation that much at all because it only, plays a minor role, let's say, in the overall emissions?
I do. There are arguments that you could make to say, well, from a sector, we have X economic benefits and that benefits the society of the world. And that, some sectors are going to be easier than others to reduce emissions in. And so we should do those first. But the reality is that we have a net zero target. That means emissions need to go as low to zero as possible by approximately mid-century. And any remaining emissions need to be extracted from the Earth's atmosphere. So we have a sink of emissions that's taking out any of those residual emissions that we're putting into the atmosphere. So we need to stabilize net emissions at zero or very close to zero by mid-century. And that means that all sectors need to play a role. And it also means that if there's a sector that continues to emit at high levels, firstly, it's going to grow as a proportion of global emissions. And secondly, it's going to have to cover the cost of those residual emissions in some way. And it would be very, I think it's a slippery slope because it's easy for many sectors to make the case that they're critical to the way that we operate today. Right? I think all sectors would have that argument. So the challenge is, how do we decarbonize in a way that is going to be effective and consistent with climate goals that we've agreed internationally? And I think you mentioned the sort of insights from road transport. This is, bringing it back to non-CO2 aviation. This is a really interesting problem because if you think about the CO2 emissions related to road transport, then you can kind of boil it down to three factors: how much activity there is, how fuel efficient vehicles are, and what the carbon intensity of the fuel is. And you can think of fuel as being a liquid fuel, or you could think of fuel as being electricity. And if you take the product of those three things, you get the CO2 emissions. And so for most transport and for most sectors, CO2 is the most important greenhouse gas. But now we're talking about aviation. Non-CO2 is as significant as CO2 in terms of climate effects. And non-CO2 is really interesting because it's not linear associated with those three factors. And the non-CO2 effects can be vastly different for an individual flight, or depending on how we operate flights using today's technology, today's aircraft, and today's fuels. And it's really interesting because in some respects, and it's been presented as a low-hanging fruit, and in some respects it is, but it also shows us the challenge associated with changing the way that we're doing things today in order to reduce climate effects. And even something that looks like a low-hanging fruit has a lot of different hurdles to jump over.
Yes, and we've spoken initially upon Alejandra's question about the progress that has been done and certainty that has been gained, and also in which parts of the, let's say, process chain we do have certainty and where not. So that has all been great progress. And now you mentioned the hurdles. Of course, one could also say it's great that we have the opportunity, because it's not about decarbonization per se, it's about the temperature, right? That is the final goal. And now we have this tool at hand, let's say, that's called non-CO2 effects, and in particular, contrail management, let's say, which could help achieve that final goal. And therefore, what are the hurdles right now? So the technological challenges to, let's say, enable contrail management.
So first, let's unpack that statement, because I think it's a really important statement that you make there about temperature, right? That the goal is temperature. And I think there's something that we have to recognize and get our heads around in the scientific community, policy community, industry community, is that there are these international agreements, the Paris Agreement, which agrees, all countries have agreed to limit global temperature rise to 2 degrees and as close to 1.5 degrees as possible. So that's the overall temperature rise. And there's some then details around exactly how that's done, but really that it's lacking in detail in exactly how that's done. But the agreement is we don't want temperature to go above 2 degrees beyond pre-industrial levels. And so if you put it like that, then the framing of the question becomes not, and this is often the question that we get asked, right, is what is the right climate metric? But then it has to be said, well, okay, we have this temperature goal. So in that context, what is the right climate metric? And I think we need to reframe the problem, not around, overall looking way out into the future. What are the climate impacts? What are the best ways in order to compare CO2 versus non-CO2? I'm sure you've covered in previous episodes how you have different time horizons in climate metrics, and you have different times over which non-CO2 affects the climate versus CO2, for instance. So climate metrics help us to provide an exchange rate, as it were, to compare CO2 with non-CO2 effects. And if we then say, well, there's a temperature goal rather than a radius forcing or emissions goal, that does change the way in which we need to look at climate metrics. And it sets then, in some respects, it sets the time horizon that we need to be looking at. So there's some other kind of academic work looking at that. And I think we need to help move that discussion forward, because otherwise we end up in a circular argument where science says choice of climate metric is a policy decision. And policymakers say, well, we need more information about different metrics and uncertainties. But what we're forgetting is that there's an international level agreement that has set the policy to be 2 degrees maximum warming. And so what climate metrics make sense on that time horizon and for that goal?
So first, I wanted to ask a question because you mentioned the word uncertainties, and I want to address the elephant in the room, which is the uncertainties, at least from our point of view, from the operational side. But then I also want you to say, okay, which is the metric that you would recommend personally, or which one do you think is best? And then for the uncertainties question. So I feel like the word uncertainties gets thrown out a lot in all sort of events, within our customers, within airlines, ANSPs. Everybody talks about uncertainty as this big whole trending hashtag on TikTok. I don't know, like everybody talks about it. But there's very little actual information, or somebody tell you the uncertainty is this much. Could you explain to us, or also then for me to be able to go to people who ask, who are not as scientifically experts as you or Marius are, can you explain in simple words what the uncertainty is? What are these values of uncertainty that we're dealing with?
Let me first, on behalf of the scientific community, say, that we should be better at communicating what we mean by uncertainty. And I think we make the assumption that when we say uncertainty, it's interpreted, it's easily interpreted what we mean by that. But you can have uncertainty that stems from different sources, and you can have an uncertainty on something that is relevant from one perspective, but is irrelevant from another perspective. And if I kind of give you a concrete example, there is uncertainty in the net radiator forcing associated with contrails on an annual average basis. And that's been documented in the literature. So there's quite large uncertainty bars for net radiator forcing. But most of the studies fall within those uncertainty bars that have been established. They are larger than for CO2, but they also account for the fact that there is, firstly, some process understanding that we need to improve. There's variability in things like weather and where aircraft fly. There's variability in the conditions that allow contrails to form and persist from year on year. So there's slight differences from one year to the next year. Whereas the uncertainty on predicting the contrail effects of a single flight, now for that flight, they might be very large because they depend on the weather forecast uncertainty, and weather forecasting has lots of uncertainties, deals with uncertainty all of the time. When we look at the weather forecast, there is uncertainty in that. We just don't see it. So we, I think, need to come to a common language about uncertainty, because what your question is sort of identifying is that uncertainty is spoken about everywhere, but actually it means different things in different contexts and for different applications. So when you're trying to predict where contrails are going to form, that's a different type of uncertainty than the uncertainty on the contrail net radiator forcing. And if we reduce the uncertainty on where we can predict contrails to form, that's not necessarily going to change the uncertainty in the contrail net radiator forcing. So they're not necessarily linked in that way, but we have to be more specific about where we're talking about the uncertainties being.
And also the magnitude of these uncertainties, because I feel like everybody says uncertainty, but this carries a huge spectrum of very big to, it's very vague. So I should say it's thrown out a lot, and it's not really clear what you mean by that. And also another kind of like uncertainty, or I wouldn't say it's uncertainty, but as you say, the range of energy forcing or how warming this is compared to CO2 is also something that is kind of discussed a lot, this fear of doing more harm than good. And even though, especially on your paper, on previous papers, and even the paper we wrote with the AAL simulation, where we showed that the fuel increase doesn't have to be that high compared to what usually people kind of discuss, is still this big fear of what if you're doing more harm than good? What if burning CO2 is going to lead to these trajectories being worse? Given also the uncertainty of, are we actually right with our predictions and so on? So what do you have to say about this? Like, is this still the best way to go? Is burning more CO2 going to be worse in the long term? Or can you answer this question for us?
There's a lot of dimensions to that question, Alejandra. But let's take the CO2 thing, because that's what you ended up with. And so that's getting back at the sort of how do we relate contrail effects to CO2 effects. And so we use climate metrics to do that. Now, also, when people talk about CO2, I think that there can be an assumption that the additional fuel burn associated with diversion of flights, rerouting of flights to avoid contrails, might be of the order of a few % of increase in fuel burn. But I think there's more and more evidence that it's sort of less than a percent or less, I would say, as an estimate from more and more studies. Obviously depends on a specific flight. It might be slightly more, it might be much less. And then if you put it in those terms, so that order of magnitude fuel burn, we published a paper recently with Nicholas Bellowan's group. And really, when you look at the contrail effects of the most warming flights, okay, these are the flights where the contrail effect is very significant, then that contrail effect is several orders of magnitude larger than the additional CO2 that is produced. And that's irrespective of the metric that you use. So even if you choose a metric that favors CO2 by having a very long time horizon, it still makes sense on that particular occasion to do contrail avoidance to avoid the additional CO2, to avoid the non-CO2 contrail effects with the trade-off that you're producing a little bit more CO2. So there's ways that we can use metrics to look at that decision. I would say, though, that on the practical implementation of this, we need to be pragmatic. Uncertainty is something that we deal with all of the time. Engineering deals with uncertainty all of the time. And maybe we just don't realize it because it's done. It's done for us. Engineers before us have done it. But in everything we do, there has been uncertainty that has been accounted for to make anything work. So we can be pragmatic, and I'm in no way suggesting we charge ahead and don't think about uncertainty, but we can do things like measure, we can observe, we need to improve our use of remote sensing capabilities, satellites, etc., to look at whether we are taking appropriate actions, whether the actions that we are making on contrail avoidance are having the effect and not having unintended consequences. And we need to be open and transparent about data on fuel burn and additional CO2 penalties. That is the only way that we're going to make progress, but we can make progress. We can be pragmatic about this.
Just real quick, I want to share an example how I handled uncertainty this summer. I think it might be something that people can resonate with because it was a very sunny summer. However, there were also very cloudy days. And when I went outside, I put on sunscreen, even though I didn't know exactly when I would be walking underneath a cloud, or I don't know exactly whether this one cloud or this one day would contribute to a skin cancer. The most pragmatic approach that I took was I put on the sunscreen. And maybe this is also like an illustration of, you don't have to know everything to know what's the right thing to do next.
Advice from Marius to the audience: skincare always comes first.
Yes, and you get this advice for free here. You're welcome.
But yeah, that's great, Marc. I mean, yeah, we totally agree. And from our side, what we want to show is, as you say exactly, be transparent with the fuel data that it burns. So then we can compare that with the contrail avoidance. And this leads to the next question, which is the question of trials. We've been discussing for a long time the possibility of doing trials, but it seems that from experiment perspective, it's kind of hard to set, because even if you do it with one specific airline, that's what Flight Keys is doing, of course, one airline, even though the data is always useful, it doesn't show the big picture, right? It doesn't show how the entire airspace would change if we just change thousands of flights, because maybe an airline can change 1 or 2 per day. So I know this is, again, very vague questions, I'm sorry, but what type of experiment, what are the challenges or kind of data that you would say would be useful to set up a trial? So how can we set up a trial from a scientific point of view? Because many times airlines want to test them from their own knowledge. I want to know how much fuel I would burn. I want to know how that would cost for me. And they do it separately from other airlines. And we want to kind of like include science into these trials to make sure we take the most out of them, and not just for the airline to know what it means for them, but kind of like involve the scientific community and see how we can advance. How can we use the data from these trials to move your research, for example, further?
I think it's a great question. And there have been a number of trials, which, as you say, have been usually one airline involved. Then we're not looking at any kind of significant changes to overall traffic. I mean, maybe the MUAC trial is the most closest example to what we would envisage as an airspace scale trial, where they attempted to move all flights based on a contrail forecast. It was voluntary, and it's been documented in the literature. But going back to your question, I think there's two parts of trials. The first part is, can it be done, and implement feasibility in operations. What systems need to be set up? What are the data flows? Who needs to be involved? Those are the kind of operational benefit, the things we learn about how to operate contrail avoidance in the real world. So that's important because we need to establish that there are ways to do this, and we can continue to refine those. The second part of it, though, and your question was getting at, was how do we start to demonstrate the climate benefit of these trials? And it is hard to do with individual airline trials, because, I mean, if you kind of ask a scientist, how do you do an experiment? Well, the first thing that we would usually think about is, how do you measure the outcome of that experiment? And so I think measurement is key, how we are measuring the sort of baseline, as it were, and then how we are measuring the change that results from any action that is taken. Now, on a single airline where you have a handful of flights that maybe are doing contrail avoidance on a specific day, then the measurement would be around, how do you identify the contrail impacts associated with those specific flights? So you need a much higher capability of measurement if you want to look at individual flights. And that has been done. Google, Breakthrough, American Airlines have some information on the web online about the trials that they've conducted on that, looking at contrail length, etc. But then if we want to kind of do this on a larger scale, both on the operational side, there's what are the effects of multiple flights all doing this thing at the same time, right? So that's an operational problem. But then the sort of science problem is, what's the climate benefit? Well, actually, the threshold for measuring climate benefit on a larger scale is slightly lower than it would be for measuring the climate benefit associated with small numbers of flights, because we could look at contrail cirrus, we could look at contrail cirrus formation. We would know that all flights within an airspace are taking action, that there is a treatment that all of those flights are receiving, and we could measure at the airspace scale what the contrail cirrus coverage is. So in some respects, it enables us to have more confidence in the measurement by expanding the physical scale of a trial. And it also helps us to understand the operational aspects of what happens when lots of airlines are doing this. So I think that's the next step, right? We need to go to larger scale trials that cover physical areas of airspace where all flights are doing the same thing. And then we can kind of take a scientific approach to that experiment, but we can also learn from other sectors, industries, where this idea of trialing something and measuring the outcome and making you very sure that there is a benefit to that outcome before you then proceed. So you can kind of step through. Medical companies do this all of the time when they're testing new drugs. They need to demonstrate in a series of trials that drug is having the effect that they want and not having undesirable, unintended consequences. That's what we need to do.
Sort of like an A/B test.
An A/B test, or you might call it a randomized controlled trial, where you can envisage how you might do that. You do that on some days, you would do contrail avoidance, on some days you wouldn't, and you'd want to be able to measure a significant difference in whether contrail avoidance did reduce contrail cirrus coverage over an airspace.
You've just mentioned an aspect that is very, I'd say, even promising, and that hasn't been discussed on this podcast before. So I want to stress it one more time. And that's the fact, maybe there's something like a critical threshold or a critical mass when it comes to these trials, because of this gap in certainty, let's say, to do contrail management, that is the prediction, but also, determining the impact on a per flight basis versus on a per fleet basis or with multiple flights, right? Because of this gap in between, maybe if we, have bigger trials, we can close this gap.
Yeah. Okay. Well, now going from something that you mentioned in your last answer, Marius gave me the honor of asking the question that has been passed on from the previous speaker, Marilyn Bastin. What is your opinion on the MRV implementation for contrails? Is it the right tool to incentivize airlines?
I'm not convinced that we should be thinking about contrails and non-CO2 in the same framework that we think about CO2. Let's have the outcome, the desired outcome as the driving factor for how we design policies and regulations that incentivize airlines and ANSPs and the entire industry to reduce contrail climate effects. If we think about them in terms of CO2 and CO2 equivalent, then that requires us to choose a metric. It comes into difficulties about associating with contrails with specific flights that airlines operate. And so some of those are going to be really challenging questions and could get tied up by challenges. So I think we need to really think very carefully about how the appropriate policy leads to a desirable outcome, which is ultimately to reduce non-CO2 effects. We know it can be done. I say pretty sure it can be done. So what is the right way to do that? And I wouldn't force it necessarily into an MRV, into a CO2 monitoring style thing, because I'm not convinced that that is the right framework for it. That's my personal opinion.
Great.
Mic drop.
Great. And we were all smiling when that question was asked, because it's the tradition of the podcast to pass on the most difficult question, it seems, to tease a little bit the next guest maybe. You also have that chance. And our next guest is Dr. Paul Hodgson from the Aviation Impact Accelerator. Any question that comes to mind?
Well, I know Paul very well.
Paul is getting a very hard one.
So if we think about policies as being carrots and sticks, right? Carrots are things that incentivize action, sticks being regulations that enforce action, really. What is the balance that Paul thinks of carrots and sticks? I think we're seeing that maybe the carrots that we thought might exist being, say, public perception of airlines making action on climate change, and airlines being able to say things about that we have to be very careful about making really strong claims. So yeah, what is the balance of carrots to sticks? What are carrots that we can help put in front of airlines and industry to do this? And at the same time, what sticks do we need?
Great one, and a classic one, an important one. We'll take it on. And to wrap up this episode, first off, a big thanks to Alejandra for a great appearance as a co-pilot. After being a guest now, great appearance as a co-pilot as well. So thanks a lot for that.
I can't stay away. Thank you. Thank you, Marius, for inviting me. I'm always happy to return.
That's really great to hear. And of course, also, Marc, a big thanks to you. And you now have to head to a lecture. So we appreciate your time and all the best.
Marius, thanks for having me. And Alejandra, good to speak to you again. It's been a pleasure.
Likewise. Speak soon.
See you.
Bye-bye.